Hi everyone, and welcome to this presentation. Today I'll be presenting you Fermentis dry yeast solution, the ones to produce spirits. Just a little bit of background. Fermentis do produce active dry yeast for the beverage industry, which includes spirits, of course, the brewing industry, the wine, etc. So just a little introduction about myself. So you know a little bit my background. So my name is Gilles Goemaere. I'm coming from Belgium. My job within Fermentis is technical sales support. So I support the sales team in Europe for any technical topic. I have over 10 years of experience in the fermentation industry, and I've been working within Fermentis for 2 years now. And for the background of the study, I'm a bioengineer, specialized in beer science, and I had the chance to go to the Catholic University of Louvain in Belgium. So today I'll be presenting first, an introduction about yeast in general and yeast for distillers in particular. Then we'll go over some characterization of yeast and important selection parameters for spirit yeast, depending, of course, on the media and the experience you want to make. We'll go over some optimization of fermentation for first the neutral alcohol, gin, vodka, stuff like this, and then we'll cover also some whiskey part. You'll see that the whiskey yeast strain is very diverse, and finally rum also to wrap it up. Of course, there is many more spirits from around the world, so this is only a selection of yeast strain for those drinks. Just as an introduction, a little reminder, before distillation, you have the alcoholic fermentation, and that involves glucose and fructose sugar most of the time, and also maltose. We'll see that later on, that with yeast is fermented into ethanol, and it produces also carbon dioxide. And along with that, the yeast is able to extract some energy under the form of ATP, so adenosine triphosphate, which is the universal energy storing vector within living microorganisms in general. So the yeast is going to use the sugar in order to extract energy and byproducts, is ethanol, carbon dioxide, and also other molecules. We'll see that later on. So in terms of sugars, the yeast Saccharomyces cerevisiae can use different sugar, fermentable sugars. The main one, the easiest one being glucose, but the yeast is also able to use maltose and maltotriose, which are maltose is 2 glucose bonded together, maltotriose is 3, and yeast will prefer the simple sugar first, and so the single sugar that is here on this graph will be fermented very quickly. So here you have the content of fermentable sugar, and you have here the fermentation time. So simple sugar go first, and then the yeast will turn to maltose. Most cerevisiae can ferment maltose, and then lastly to maltotriose, but not all the yeast can ferment maltotriose. Of course, this is the main part, production of ethanol. And here you have a summary of this metabolic pathway, which is the glycolysis and then the fermentation here. But you have also some secretive fermentation metabolisms. So yeast will produce some fatty acids, will also produce some aldehyde and some sulfur compounds. Those are mainly off flavor, non-desired flavor, but all the yeast do produce them. You have also higher alcohol and esters that are most of the time the desired aromatic compounds, not always. When you want to have neutral spirit, you don't want to produce too much of them. If you want a more fruity spirit, you will tend to go towards those molecules. And then lastly, some organic acids that will reduce the pH during the fermentation. So after this short introduction, let's turn to some consideration when selecting yeast strains. So first, there is countless yeast strains available. Every strain has unique characteristics. So, for example, sugar utilization, aromatic profile is specific yeast to yeast. And then so the yeast has some behavior, we call it phenotype, according to process parameter, the raw material, and etc. And so you will want to select a strain that is suitable for your specific spirit, your specific substrate, and even also to your process parameters or your material limitation, etc. And then after, you can also turn to the process parameter in order to steer, we call it steering the yeast in the right aromatic direction, if I may say. So if I want to select a yeast according to the substrate, I can use this table. So you have here the strains of Fermentis, so we call SAS spirit, and then you have the strain name. So here M1, US, W6, and etc. And you have here the main application, so whiskey. GNS is grain neutral spirit, and you have also some that are more for light rums, for neutral alcohol base also can be used. Rum, here you have the neutral spirit also, and you have some more specific. And of course, depending on the main application, you have main substracts, so malt and cereal. So cereal will not be malted, of course. Some yeast are adapted to molasses, to starch vegetable, to beet juice, etc. And then you have also the phenol characteristics. Some yeast, most yeast are phenolic positive, and some yeast are phenolic negative, and that may be important for, especially for whiskey. Introduction also to the fermentation dynamic. So this is a trial in synthetic media, and only glucose was used, and then one single fermentation conditions, 24 degrees Celsius, 50 grams per hectoliter, and a 20 Plato or 1083, it's the same number, a different number to say the same thing. And here you have the fermentation time in days, and you have the ethanol produced, and the experiment was stopped after 6 days. And you can see that most yeast will ferment pretty quickly, and roughly after 3 days, they will be able to reach this 12% alcohol. Here you have M1, that is a little bit slower, but we definitely know that 1 or 2 extra days it will reach the same target. We'll see that M1 has a optimal fermentation temperature that is higher. That explains also why it is lower. And here you have the results in terms of ethanol after 6 days, depending on the yeast strains. If we turn to sugar, some yeast, all yeast have the ability to ferment simple sugars, glucose, fructose, maltose. Maltose being already complex, sorry about that. And some yeast have the ability to ferment maltotriose, and even some yeast more complex sugars. So for example, M1 has the ability to ferment DP1 is degree of polymerization 1, DP2 degree of polymerization 2, which is maltose, DP3 maltotriose, and dextrin is over So it's starting from degree of polymerization 4 and higher. And most of the yeast can ferment at least up to a degree of polymerization 2. And you have some information about maximum alcohol possibilities for the yeast. And you see that HG1 is very interesting because you can ferment up to 18, even a bit more alcohol with this yeast. So it's very interesting, and most yeast in right conditions, in controlled conditions, you can reach up to 15% alcohol. We also have to take a look at the temperature. So the temperature we'll talk about thermotolerant yeast and less thermotolerant yeast. The advantage of thermotolerant is that you don't have to use or you have reduced cooling requirement, which can be a very good advantage. The fermentation will also be faster, have reduced cost, and less thermotolerant yeast, of course, in some cases you will have to cool down more, which will bring the cost up, but at the same time you will have other aromatic pathways that will be available. So it can also be interesting. But you have to know about this in order to choose the right yeast for your process. So information about temperature, you have here the yeast range, and you have also the temperature range. So let's say that it would be the temperature at which the yeast will be able to ferment. And then information about thermotolerance. And thermotolerance can be two things. First, resistance to heat. So some yeast over a certain temperature at the start of fermentation will perform less. And then you have also thermotolerance regarding to alcohol, because when you reach a certain level of alcohol, it becomes to be toxic to the yeast, and higher temperature increase the toxicity of ethanol to the yeast. So example of M1, it goes well from 20 to 32, but optimal temperature for fermentation dynamic is 32. Medium alcohol tolerance, and HG1, again, of course, it can reach 18% alcohol as high thermotolerance, and we'll see a little bit more in the next slide, and I'll let you discover for the rest of the range. So this is an example of the temperature, and then you have to take into consideration speed, maximum alcohol produced, and etc. So in this graph, you have here information about fermentation dynamic. So the higher you go in this axis, the faster you go in fermentation. And here you have information about total ethanol produced, so gram of ethanol per kilogram of media. And what we can see from here, so this is sastric HG1 at a fairly high concentration, is that the fermentation is faster when it starts at 35 degrees Celsius. This is very clear. And here, for example, at 40 degrees Celsius, you see that you have a slower fermentation start. So the yeast start to have difficulties with the heat, and also the toxicity of ethanol is a bit higher. And you see that with this yeast, you reach the optimal spot between 28 and 32 degrees Celsius. Let's have a look at the vodka gin, so all the neutral alcohol base. First, the example of vodka. So the main purpose of vodka is ethanol yield. The goal is to have as much possible limited off notes, the highest neutrality, so low levels of congeners, and fast kinetics to optimize the cost. So temperature is usually between 22 and 26. degrees Celsius. If you go in higher temperature, you get some losses and also higher flavor. Pitching rate fairly high of over 50 grams per hectoliters. And it's rated even a little bit higher to avoid some losses towards the biomass production and important sterile conditions, also to avoid any off flavors. And so if you look at the distillation of vodka, you can also have optimal temperature for ethanol, and that will allow you to avoid too much aroma compounds and of flavor also. Here's just an example of the Russian standard, which is a brand of vodka. They have two class, first class and extra. And here is just the acetaldehyde allowed for these specific classes, higher alcohol and esters, and you can see it's very, very towards the neutrality. So for a neutral alcohol spirit, we have three nice selection of yeast: Saspirit GR2, Saspirit C70, and Saspirit HG1, each having their particularities. So GR2 is regular kinetics and avoid peaks at high temperatures. It's well suited to plants that have a good temperature control. C70, very robust, doesn't need a lot of nitrogen, so it's a very well multi-purposed and wide range of temperature. And then HG1, a very fast kinetic and thermotolerant, so it's well suited to ferment at high temperature to optimize the efficiency and cost. So now let's turn to another kind of spirit, the whiskey first, Scotch whiskey. So we had a program some years ago about selection of a M-type yeast. So the M yeast is the widest yeast strain used in Scotland for producing whiskey. So the target was to meet flavor and cost effective. So it's you have a need here of maltotriose and even dextrin fermentation, tolerance to alcohol and temperature, fast fermentation, and this was all tested with the Scottish Whisky Research Institute. So the M1, so Saspirit M1 selection was made with a lot of laboratory trials at standard high gravity. We used a wash directly from our distillery that was homogenized before fermentation, and we used compressed M-type yeast as control from several sources. In the fermentation conditions, the start of temperature was pretty low at 19 degrees and allowing the heat of the yeast to raise the temperature up to 33 degrees Celsius after 36 hours. And then it was distillated and diluted back to 20% and analyzed and also tasted by a panel. If we look at the fermentation kinetics, you will see in dotted line, you have the high gravity that all starts here, and the plain line is the lower gravity. And as you can see, there was absolutely no difference between the two reference yeast strains and the Saspirit M1, and they all had an average of 95.8% of fermentation. In terms of flavor, tasting panel, here you have two spiral graphs with some attributes, let's say. And on the left-hand side, you have the Saspirit M1 at the standard gravity, And here you have the control. Of course, we have the data for all the trials, but just a selection to show you. And it's pretty clear that you have a flavor match between the two. So if you go high, you get higher in this attribute, and you have a perfect match between the two strains. And then lastly, just this is information to show you what we analyzed. At the end of fermentation, you have all these superior alcohol and esters that were analyzed, and also same was analyzed at the end of the second distillation. It was a match for the expected range of congeners. So I've said already that sensory profile met expectation. So great yeast for Scotch whiskey fermentation. Let's have a look at some Japanese whiskey strain selection. It was an interesting program. First, a little bit of background about the Japanese whiskey. Most of the time, it's imported malted barley, distilled twice in pot still, and it's aged in ex-bourbon or sherry cask. So the heavy innovative production, they allow to have multiple yeast strains to produce different style of whiskey. They have also a lot of variation in the distillation design. Faster rate of maturation, and this is the most important thing, a broad range of distinctive flavor and profile. So we had a strain selection by a distillery. So let's say that the concept is to make what is so-called new make spirits. And the goal, the trial, the objective was to produce as fruity as possible whiskey. So a lot of yeast were assessed, and you had fermentation in a lab, in pilot, and finally production. Of course, I have to summarize the results. So what was first assessed was what was the key compound in order to produce a very aromatic, fruity aromatic whiskey. So here in the first graph, you can see a level of a certain compound that is called isoamyl acetate. This linked to a banana, candy, pear flavor. And in a strong fruit whiskey, you could expect to find 40 ppms of this this compound. So this would be a 14 years old age whiskey. And the program, they had an experiment to add external isoamyl acetate to go from standard to over 100 ppm, and then they tasted side by side, and they found out that increasing the concentration of this isoamyl acetate allowed to reach a very, very nice fruity flavor that was somewhat similar to the aged whiskey, very fruity. And so the last part of the experiment was to assess large number of yeast in specific conditions to see which ones were able to produce the highest amount of isoamyl acetate to get the fruity spirit, and Sasprit D53 was therefore selected. So as a summary for this study, D53 is a strain for fruity new make spirits. It's Cerevisier. The optimal temperature and pitch rate to achieve the fruity fermentation would be around 30-32 degrees, and from 30 to 50 grams per hectoliter. And the expected is white fruit and tropical fruit. And the optimal fermentation is allowing you to reach over 100 ppm of isoamyl acetate. So to wrap up the whiskey strain summary, you have the substrate M1, this towards the Scottish whiskey. You have also the substrate US W6. I didn't talk it much about this yeast, but it's more towards the American whiskey, towards the other grain distillates from USA, and then you have also a very fruity new make spirit with the D53. Let's talk also a little bit about rum strain selection. So of course, the rum has a completely different base for fermentation. It can be sugarcane juice for rum that is called agricole, and also you have molasses, sugarcane for molasses, for instance, for other types of rum. We all know that rum is produced mainly in Latin America. The cane juice and molasses, they have a very low amount of nutrient and nitrogen. And most of the time, traditional rum, there is no nutrition that is added, which may bring low efficiency, slower fermentation start, and possible stuck fermentation because of lack of nutrient. Also, high volatile acidity and poor temperature control, not in all the cases, but possibly. And so the yeast selected needs to be able to cope with that specific parameters for rum fermentation. Just a summary of what the nutrition can be helpful for. You have here a control fermentation, and you have also different addition of DAP. DAP is diammonium phosphate, so it's mainly a source of nitrogen, and you can see that the control in blue here has no addition, and then red, green, and other lines F addition, this one having the most DAP. And you can see that you have a clear link between the amount of DAP and the dynamic, the speed of the fermentation. So the yeast selection for rum is in the ideal characteristics. It would ferment simple and only maltose. It would have a resistance to low nutrient availability, and also to resist for the temperature. So we have also a very nice selection for rum, so C70 and HG1. So the first one has the ability to ferment up to 35 degrees Celsius, though 30 degrees Celsius would be a bit better for toxic tolerance towards ethanol. Preferred raw material would be juice, and then it would be, let's say, a lower initial gravity, and also a lower nitrogen need. And on the opposite, is substrate HG1 that can withstand a little bit higher temperature, that will work better with molasses, and that will bring you higher potential alcohol, so you can use a higher initial gravity, but at the same time, higher amount of nitrogen need. So I'd like to thank you very much for attending this presentations. I hope it helps you to have a better understanding on our nice spirit yeast range. And I'd like to wish you a good day, night, afternoon, whenever you are watching this presentation. Thank you very much.